Hello. Hello. I don't. Okay. All right, I'll start. Okay, I'll start. Good evening, students. How are you all? So, welcome to the next session of arithmetic progression. In the previous class, we discussed about arithmetic progression. We discussed about sum of n terms of the AP. And earlier, before that, we had discussed about nth term of the AP. So today, coming to the sum of the n terms of the AP that we had discussed earlier. So we'll quickly revise what we did in the previous class. Now, we'll revise quickly the formula for the sum of the n terms of the AP. That's denoted by Sn, sum up till n terms of the AP, that is given by n by 2 into 2a plus n minus 1 into d. So where a denotes the first term, d denotes the common difference. We can use this formula, or we have two more formulae. So I'll write it down, the next one. Sn, that is n by 2 into a plus an. An denotes the nth term of the AP. So if we want to calculate the sum of the n terms up till a particular term, like up till the 10th term we want to solve for the sum, then in that case we will use this formula where we know the nth term. We know, like for example, I just told you that if we want to solve for sum of the first 10 terms, here an refers to sum, the 10th term actually. Now coming to the sum of the n terms of the AP, when we have a finite AP, we have to solve for the sum of all the terms of the AP. That would be n by 2 into a plus L, where L refers to the last term. It refers to the last term. So starting from the first term till the last term, if we want to solve for the sum, we are going to use this formula. So as I just told you in the previous class also, that we can use any one of these formulae depending upon the question. So that we will decide when we are going to see the question. We will see that what is given to us and what is required. Accordingly, we'll pick up any one of these formulae. Now I am discussing the next question, page number 112, exercise 5.3, question number 2. Question number 1, I think we had already discussed yesterday. Now coming to the second question. So that's similar to the previous one only. Find the sums given below. So we have the first AP here. We have 7, we have 10.5, we have 4, 14 and so on up till 84. So starting from 7, this we can write as 10.5. Then we have this one as 14 and so on up till 84. So just for convenience, I have written this as 10.5. Now please notice these numbers, they're forming an AP where the first term is 7. The common difference here is 3.5. It is 3.5. Now we have to solve for the sum. That means we have to solve for all the sums starting from 7 to 84. So we know the first term is 7. We know 84 is the last term. So how to solve for the sum? That is Sn is equal to n by 2 a plus L. So we are going to use this formula. So if I am putting the values here, I don't know n here. I know a, that is 7. I also know here L, that is 84. That's the last term, 84. But then how am I going to proceed if I don't know n? So before I do anything else, I'll first solve for n. So please notice, we're going to pick up here 84. 84 is the last term of the AP. So if we know 84 is the last term, we can solve for the n terms of the AP. That means we can solve for the number of terms of the AP. So number of terms of the AP, we are going to solve using the nth term formula. An is 84. So we can write this as a plus n minus 1 into d is equal to 84. So here a is 7. Then we have n minus 1. We don't know n. We know d is 3.5. And this is 84. Now 7 will go on the other side. It will become minus. So we have n minus 1 into 3.5 is equal to 84 minus 7. So this would be n minus 1 into 3.5, that is how much? 77. This 3.5 we are going to take on the right hand side and it will go in the denominator. So this will go in the denominator and we will get n minus 1 is equal to 77 upon 3.5. Now if we cancel out this, I'll just write it again here, n minus 1 is equal to 77 upon 3.5. If we cancel out this, we are going to get here 22. So we have n here as 23. How did we get this 23? 1 will go on the other side and will become plus 1. So n is 23. Now I'm going to pick up this 23 and I'm going to put it here. So I left my question here because I got stuck here since I was not knowing n. So now we can put the value 23 here. So we have Sn as n by 2, 7 plus 84. Students, please notice I'm just copying down this particular step. That's all. And now I'm going to put n here. That's 23. So that's 23 upon 2 into, we can just add these two. 7 into 84 will give us 91. And this is what we are going to get. So there's no cancellation possible here. So we are going to now multiply 23 and 91. So let's solve this. 23 times 91. Let's see how much do we get. We are going to get here 3, 23, 0, and then 9, 3s are 27. 7 we are going to write here. 2 we are going to take carry over. 9, 2s are 18. Add 2 to it, you will get 20. So this would be 3. Then we have 9. Then we have 0. Then we have 2. So now finally, Sn is 2093 upon 2. You can either leave it here or if you want, you can write it in decimal. Both ways it is correct. So in such questions where we know the first term and we know the last term, but then we need to solve for the sums. But please notice here we don't know n. We were not knowing n. So the first step is to make sure that according to the formula, everything you know. So A we know here, D, and we also know the last term, that's 84. Now using the nth term formula, we are going to solve for n. And whatever we'll get the value of n as, we are going to put it here. I hope students, this is clear to everybody. Now let us proceed further. Now the next one we have 34, 32, 30 and so on up till 10. So this is also an AP. We can see that the common difference here is minus 2. Please notice here the numbers here are decreasing. So if they are decreasing, that means the common difference here is a negative number. So here A is 34, that's the first term. D is minus 2. There's a difference of 2 throughout and the numbers are decreasing. So the common difference is minus 2. Then the last term is how much? It is 10. Now again we don't know n. Please notice I'm going to use this formula. Sn is equal to n by 2 a plus l. Now even if I use this one or this one, any one of these, then also I need n. So I can pick up anything as per my choice, but in any case we need n here. So I'm going to first solve for n. So an is given by 10. That is the last term actually. I have replaced this an by 10. Now we can write the nth term as a plus n minus 1 into d is equal to 10. And a, I'm going to write here 34. N I don't know. I need to solve for that. D is minus 2 here. And then we have 10 here. 34 will go on the other side. And it is going to become n minus 1 into minus 2 equal to 10 minus 34. So this 10 minus 34 can be written as minus 24. So we have n minus 1 into minus 2 equal to minus 24. This minus 2 I'm going to take on the other side. I will get n minus 1 is equal to minus 24 over minus 2. So this is going to become 12. So finally we have n as 13. Minus 1, if I take on the other side, it will become plus 1. So here we have n as 13. Now n is 13 here. Now I know the value of a, I know l, I also know n, that is 13. So in the next step, we are going to use this formula. Sn is equal to n by 2 into a plus l. So n we know is 13. N is 13 here. I'm going to put here 13. 13 by 2. A we know is 34. This is 34. And the last term we know is 10. It's 10 here. I'm going to put 10 here. So let us solve this. We will get 33 upon 2 into, we can just add these two. We'll get 44 here. And we can cancel out and we'll get 22 here. So this is 13 into 20, 22. 13 into 22. So now we'll have to solve this. 13 into 22. Let us see how much do we get. So we are going to get here 2 3s are 6, 2 1s are 2. Then we can write 0 here. 2 3s are 6 again, 2 1s are 2. So we'll get 6 here, 8 and 2. So that is 286. So finally the answer here is 286. I hope students this question is clear to everybody. Now let us discuss the third question. Just give me 1 minute. Some technical issue. So now we are going to discuss the third question that is given in NCERT, page number 112 again. I'm referring to exercise 5.3. So in an AP, I'm reading question number 3 in an AP. So we can you see there are a lot of parts here? There are 10 parts and all. So the different combinations which we have made from A, N, N, D, all these things. And then accordingly, we have to find 1 or 2 unknown quantities. Please go through all 10 parts here. Now coming to the first one, so we were discussing this one, the first one. In an AP, given A is equal to 5, D is equal to 3, AN is equal to 50, we have to solve for N and SN. So we know A is 5, we know D is 3, we also know the nth term, that is 50. We have to first solve for N. Now please notice, if we take AN as 50, we can write the nth term formula, that is A plus N minus 1 into D is equal to 50. Now A is 5, I'm going to replace this by 5. N we don't know, we need to solve for, and D is 3. And then we will have 50 here. Now 5 I'm going to take on the other side, it will become minus 5. So I'll get N minus 1 into 3 is equal to 50 minus 5. So we can write this as N minus 1 into 3 is equal to 45. Now 3 if we take on the other side, this will go in the denominator. So we'll get N minus 1 is equal to 45 upon 3. So this can be written as 15. So we have N minus 1 is equal to 15. And finally we have N as how much? 16. Minus 1 will go on the other side and N will become 16. So now children, we have already solved for the first part, that is N is equal to 16. That we have already done. Now we need to solve for Sn. Sn here, we are going to use the formula, any of the formula, we can use any of these formula. But I think the simplest one which will go here in this case would be N by 2 A plus AN. I'll write it down. Sn is N by 2 A plus AN. We already know N is 16. We know A is 5 and AN is also given to us. So that's quite convenient to solve. So I'll put the values here. 16 upon 2 into A. A here is 5 and AN we know how much? It's 50. It is 50. So we have a 16 by 2 into how much? 55 here. This will become 55 and you can cancel out this and you're going to get here 8 and then 8 into 55. Now let's solve this. 55 into 8 will give us 0 here. It's 40. 8 into 5 is 40. We'll write 0 here and we'll take 4 as carryover. 8 into 5 again is 40. We are going to write here how much? 440. So this is 440. I hope students this question is clear to everybody. Now coming to the next one, give me 1 minute again, there's some problem. Now I'm starting with the second question here. In the second question, please children, if you have your textbooks, refer that. Given A is equal to 7, I'll just show you on the screen as well. This is taking time to load. Now given A is equal to 7 and we also know A13, that is 35. We have to solve for D and S13. S13 means sum till the first 13 terms of the AP. So we know A is 7, we know A13 is 35. Now please notice A13 is 35. The 13th term is 35. So can I write this as A plus 12D? We can write like this. I explained you this in the first two classes also. Like actually what I'm doing here, I am using the nth term formula. That's AN is equal to A plus N minus 1 into D. So if I have A13, I will take 1 less here. So A plus 12D. Also we know it's given to us in the question that A is 7. So I'm going to replace A by 7. A plus 12D is equal to 35. This 7 I'm going to take on the other side. It will become minus 7. So that's 35 minus 7. So here 12D is equal to 28. So D here is 28 upon 12. Now if D is 28 upon 12, we can cancel out both numerator and denominator by 4. So this will become 3 and this will become 7. So D now we know is 7 upon 3. D is 7 upon 3. Now we have solved for this. Coming to S13. Now if I need to solve for Sn here, I am going to use the formula n by 2 into A plus n, An. I'm using this because I know already S13 I need to solve for. I know N is 13, I know A13 and I also know A, that is 7. So S13 would be 13 by 2 into A plus A13. That is 13 by 2 into A. Let's see what is A. A is given to be 7. That is 7 here. And then we have A13. A13 here is how much? It's 35. It is 35 here. So now we have 13 by 2 into, this can be written as 42. So now this 2 and 42 will get cancelled and I'm going to have here 21. I'll get here 21. So 13 into 21. Let's solve for 13 into 21. We are going to get 1 into 3, that is 3. 1 into 1, that's 1 again. And we can take the 0 here. 2 into 3 is 6. 2 into 1 is 2. So we'll get 3 here, 7 and 2. So finally here S13 is 273. It is 273. And we've already solved for D also in the previous step. We've got D as 7 by 3. So please notice in the question, we were asked to solve for D, that we have done. 7 by 3 we've got. Also we were all asked to solve for S13, that we have solved 273. Now let us discuss the next one. Again, I'm facing the same problem. Sorry, there's some technical issue today. Now coming to the third one, please read it from the textbook itself. A12 is 37, D is 3. We have to solve for A and S12. So we have to solve for A and S12. Always keep an eye on what you want in the question. So we have to solve for the third part here. So as I just told you that A12 is 37. Please read the question that's showing here on the screen. A12 is 13. And these three we have to solve for A and S12. So before we do anything else, so we are going to solve for A. That's quite simple here. A12 we already know is 37. So now A12 can be written as A plus 11D, that is 37. We know that D is 3. So we are going to write this as A plus 11 times of 3, that is 37. And that is A plus 33 is equal to 37. This will go on the other side and will become minus 33. So here A is 4. Now we know A is 4, that we've already got. Now we need to solve for S12. Now coming to S12 here. Just give me a minute. Now, after this, we were discussing question number third one, the third one. So I'll just quickly do it again for you because there was some technical issue. So we were discussing this one. Given A12 is equal to 37, D is 3, and we have to solve for A and S12 here. Now, this can be written as A plus 11D. So that's 37 actually. That's given to us in the question. And we know D is 3. So we have A plus 11 times of 3 is equal to 37. Now this is A plus 33 is equal to 37. And finally, when this will go on the other side, it is going to become A is equal to 4. It is A is equal to 4 because we have taken this 33 on the other side. So that's how we've got A as 4. Now coming to S12. S12, we can use this formula where we have Sn is equal to n by 2 A plus An. So S12 here is 12 by 2, that is A we know is 4. I'm replacing this by 4. And An here is A12. I'll just write it down again for you. S12 is equal to 12 by 2 A plus A12. So here I've written 12 by 2. I've replaced A by 4 that I've already solved in the previous step. And then we have A12 as 37. Now we can solve this. We'll get 6 here. So this is 6 times of how much? Just see how much is this? 4 into 37 will give us 41. So this is 6 times of 41 and we can solve this. We'll get here 246. So S12 here is 246 and A is 4. And that is what was asked in the question. I hope students this question is clear to everybody. Now coming to the next one, we have A3 as 15, S10 is 125, this we know. We have to solve for D and A10. We have to solve for D and A10. So first of all, we know A3 is 15. So we can write this one as A plus 2D is equal to 15. Now, A we don't know and we also don't know D here. Please notice we don't even know D here. So we've actually got a relation between A and D here. We've got A plus 2D is equal to 15. We don't know A, we don't know D, we cannot proceed further. So for the time being, we are going to keep this equation aside and we might be using this in the next step. Coming to S10 is equal to 125. Let us write this in terms of A and B. So Sn can be written as n by 2 into 2A plus n minus 1 into D. That is S10 is equal to 10 by 2 into 2A plus 10 minus 1 into D. So here S10 we already know it's 125. So I'll replace this by 125 and I can cancel out this. I'll get here 5. So this is 5 times of 2A plus 9D. I've written this 10 minus 1 as 9. Now 5 I'm going to take on the other side. It will get divided. So 125 divided by 5 will give me 25. So this is 25 is equal to 2A plus 9D. So that can be written as 2A plus 9D is equal to 25. I've just switched the LHS and RHS here. Now these are two equations in two variables A and D and we will solve as usual. As usual means whatever we discussed in the linear equations chapter. We are going to solve by elimination method here. You can also solve using substitution method. That's okay. Whatever you find comfortable. So let us solve this one. So I'll just write the equations here. A plus 2D is equal to 15. That's the first equation we got. And then we got 2A plus 9D is equal to 25. That's the second equation. Now I'm going to multiply the first equation by 2. Now if I multiply the first equation by 2, this will become 2. And my purpose of multiplying this by 2 is that I want this coefficient to be 2. I want the coefficients to be same. So we have 2A plus 4D is equal to 30. I have multiplied this throughout by 2. So this is 2A, this is 4D and this is 30. Now I'm going to just copy down the second equation as it is. So I have 2a plus 9d is equal to 25. Now I'm going to subtract this. I am subtracting because I want to get rid of this a term. So I'm subtracting here. Now 2a minus 2a will get cancelled. 4d minus 9d will become minus 5d, and this will become 5. So finally we have d as negative 1. D is negative 1. Now I'm going to pick up this d is equal to negative 1 and I'll put it either in the first equation or the second one. That's my choice, whatever I'm finding comfortable. So for the time being, I'm putting this in the first equation. So I will get a plus 2 times of minus 1 is equal to 15. So this will become a minus 2 is equal to 15, and then we are going to get a as 17. So a here is 17. Now we were supposed to solve for d, that we have already done, that's negative 1, and we were supposed to solve for a10. We've solved for a here, that is 17, that we'll be using in a10. So a10 here is a plus 9d. That means here a is 17, 9 times of minus 1. So this is 17 minus 9. So a10 here is 8. a10 we are going to get as 8 here. It is 8. So finally, we were asked to solve for d. We've got this as negative 1. And we were also asked to solve for a10. That is 8. So here you have to make different combinations, permutations, combinations. Like you have to make use of different formulae. And please notice everywhere we'll be using this linear equations concept. How to solve two linear equations and two variables, which we've done in the previous chapter. This will be used in a lot of chapters. So if it is not clear to you, please go back and revise this. It is very, very important because we'll be using in a lot of questions in arithmetic progression and also in other chapters too. Now let us solve the next one. Given d is equal to 5, S9 is equal to 75. We have to solve for a and a9. So let us try this one. D is 5 here, Sn is 75. Now here we can apply a9 here. a9 we need to solve for. That is a plus how much? 8d. So we know here a9 is a plus 8 times of 5. So a9 here is a plus 40. This can be written as a plus 40. So I've written a9 as a plus 8d. I've replaced d by 5. I've got this as 40 and now I've got stuck. I cannot proceed further. But you need not worry, we'll be using this. So even if you get stuck and you feel that there are two variables and only one equation, you need not worry. For the time being, just keep it aside. You will be using this in the next step. Let's see how we can relate things. Coming to S9. So before I write this S9, I'm writing the nth term formula. So I'll be using the nth term formula here. That can be written as n by 2 into a plus an. This formula we are using. Let's see if we can use this. S9 if I write, I'm going to get 9 by 2. That is a plus a9. Now S9 is 75. In the next step, I'm replacing this by 75. That's 9 upon 2 into a plus a9. So now can I write this a9 as a plus 40? Yes, we can do that. A plus 40 we can write. And then we can write this as 75 is equal to 9 by 2 into 2a plus 40. We can take 2 common from here. So we are going to get 9 by 2 into 2a plus 20. Please notice we have taken 2 common here so that these terms, these numbers become small. That now it's a and 20, and we can cancel out these 2 also. So we'll get 75 is equal to 9 times of a plus 20. Now I'm going to take this 9 on the other side. I'll get 75 upon 9 equal to a plus 20, and then I can cancel out the numerator and denominator by 3. This will go 3 times and this is going to become 25 times. We have 25. Now we have 25 upon 3 is equal to a plus 20. This 20 I'm going to take on the left hand side. So this will become 25 upon 3 minus 20 is equal to a. And then we can take the LCM here. If we take the LCM, we'll get 3 here and we'll get 20 minus how much? Let's see, 25. This is 25 minus 60. That's equal to A. So A here would be minus 35 upon 3. 25 minus 60 will become minus 35 upon 3. And that is the answer. So that is what we were asked to solve. We were asked to solve for A, that we've got minus 35 upon 3. Now we also have to solve for A9. Now coming to A9, we were already knowing, we had formed an equation for it. A plus 40. So now we know A is minus 35 upon 3 plus 40 we have to write. So let's solve this. We'll get this as 120 here. And the denominator would be 3. That's the LCM. So minus 35 plus 120 in the numerator and the denominator would be 3. Now we can solve this and we are going to get here 85 upon 3. So A9 here is 85 upon 3 and that is the answer here. So we have got A also, we have got A9 also. I hope students this question is clear to everybody. Now let us solve one more. Given A is equal to 2, D is equal to 8, Sn is 90, we have to solve for N and An. Now here we know A, we know D. We have to solve for An and N both. So let us write this An as A plus N minus 1 into D. So we don't know An, but doesn't matter. Let's see what can we do about it. We'll write this as 2 plus N minus 1 into 8. We can write like this. If you want, you can simplify also. You can write this An as 2 plus 8N minus 8. And further, you can write this as minus 6 plus 8N. Let's keep it aside. Let's see what we can do about this. Coming to this Sn, we're going to use the formula N by 2 A plus An. So here we have Sn as 90, N we don't know, A we know is 2, and this An we can replace by minus 6 plus 8n, minus 6 plus 8n. So this is minus 6 plus 8n. Let's try to simplify this further. We will get 90 is equal to N by 2 and these two can be written as minus 4 plus 8n. Now we can take 2 common from here. So once we take 2 common from here, we are going to get minus 2 plus 4n. We can cancel out these 2's and we will be left with 90 is equal to n times of minus 2 plus 4n. In the next step, we are going to take this n and we are going to multiply this inside the bracket. So we will get 90 is equal to minus 2n plus 4n square. And then we have 4n square minus 2n plus 90 is minus 90. This would be minus 90 is equal to minus 90 is equal to 0. We'll divide this throughout by 2. We have 2n square minus n minus 45 is equal to 0. Now we'll solve this using split the middle term. We want two numbers whose product is minus 45 into 2, that is minus 90. And then we want the sum as negative 1. So we can write this as 2n square minus 10n plus 9n minus 45 is equal to 0. And we can take 2n common. We'll be left with n minus 5. From here we can take 9 common. We'll be left with n minus 5 is equal to 0. We have n minus 5 times 2n plus 9 is equal to 0. So this will give me n is equal to 5 and this is going to give me n as minus 9 upon 2. We cannot have n as a negative number. Not possible. N has to be a natural number. That is why here n is 5. So we've got n as 5. We can just put n5 here. If we put n5 here, we are going to solve for an in this case. Minus 6 plus 40. We'll get this minus 6 plus 40. That is 34. So an is 34 and then n we've already solved. That is 35. I hope students this question is clear to everybody. So I'm winding up here. We'll be continuing with the same exercise in the next class. And to further watch our videos, you can download our mobile app. Okay. Thank you, students.